Hello everyone, welcome back to Online Maths Hub, and of course we have this question to evaluate right here. Okay, so just pay attention. I'm going to show you how you can actually solve this. Okay, so let me write solution, and then I'm going to repeat the question. Okay, and of course as we proceed in the video, if you start getting value in the video, do not hesitate to actually subscribe to our channel and also like this video, turn on the notification icon so that if we release new content you will get to know about it. Okay, so having rewritten the question, I'm gonna evaluate this stuff right here on in the square root. So, and if I do that, I'm gonna be having that this is integral 1 over square root. So what I want to do is I want to make the coefficient of x here to be to actually be 1, and so I'm going to factorize 4 from here. And of course if I do that, I'm going to have that this is equal to 4 bracket 25 divided by 4 and then minus x squared. Okay, the x. So this is what I have. Now, having gotten this, the next thing I want to do is I'm going to, since this is a perfect square, I will bring it out and then I will also rewrite this. So what I'm going to have is integral 1 over, I'm going to take the square root of this 4 and it is actually 2. Okay, and then the square root of, I can rewrite 25 over 4 as 5 over 2. Okay, all squared, and then minus x squared, the x. Okay, so once I've gotten to this point, the next thing I want to do is actually to set my x. Let x be equal to 5 over 2 sine theta. Okay, and of course if that happens, I will have that my theta, that x, okay, making theta the subject of formula, I will divide through by the coefficient of sine theta here. And of course if I do that, I will have that this is that x divided by 5 over 2 is now equal to sine theta. Okay, and of course this implies that theta will now be equal to sine inverse of so if I evaluate this stuff right here, what I'm going to be having that this is 2x divided by 5 right here. Okay, so what I'm going to do now is I also want to differentiate this with respect to theta. So I'm going to be having that my dx is equal to 5. Okay, that my dx is equal to 5 over 2 cos theta d theta. Okay, so once I've gotten all of these things, I can go back to the question and substitute. And if I do that, my integral, it will change to 1 over 2, and then the square root of 5 over 2, okay, squared, minus, and then of course I have that my x here, I've set my x to be equal to 5 over 2 sine theta. Okay, and then of course this is also going to be squared right here, and then I'll have that my dx is equal to, so this is my dx 5 over 2 cos theta. Okay, cos theta d theta. So this is what I have right here, and then I can go ahead to evaluate. I can even bring out this constant right. So if I do that, I'll be having that this is equal to 1 over 2 integral 1 over, so square root of, I can also bring out this 5 over 2. Okay, so 5 over 2 squared, and if I bring it out, what will be left here is 1 minus sine squared theta. Okay, so that's what I have, and then it's also multiplied by the x here, which is 5 over 2 cos theta d theta. Now this is what I have, and then moving on again, I'll have that this is 1 over 2 integral. If I bring out this, if I take the square root of this, I'm going to be having that this is 1 over, okay, 5 over 2 multiplied by 1 over okay, the square root of, if you remember this relation right here, if you remember the relation that cos squared theta plus sine squared theta is equal to 1. Okay, so which implies that from here that cos squared theta is actually equal to 1 minus sine squared theta. So that's, I'm going to replace this 1 minus sine squared theta with this cos theta right here. And of course, if I do that, I'm going to be having that this is a cos squared theta right here. Okay, and then it's multiplied by 5 over 2 cos theta d theta. Okay, so I'll proceed, and of course this is what I'm going to be having, 1 over 2 integral, this is 1 divided by, so let me just take the square root of this, and of course if I take the square root of that, what I'm going to be having is of course 5 over 2 is here, cos theta. Okay, and then of course it's also multiplied by 5 over 2 cos theta d theta. Okay, now this is what I have, and of course this 5 over 2, this 5 over 2 cos theta can also cancel this 5 over 2 cos theta, and what I'm going to be having is that my is 1 over 2 integral d theta right here. And of course if you integrate this, you have that this is 1 over 2 theta plus c, okay, which of course is equal to theta divided by 2 plus c, the constant. And of course our theta, if you go up right there, our theta here we actually evaluated it to be a sine inverse of 2 over 5 divided by 5. So I'm going to replace it right here, and of course this now implies that my answer will now be equal to sine inverse of 2 over 2x over 5, okay, and of course is divided by 2 right here plus c. I can also write it as 1 over 2 into sine inverse of 2x over 5, okay, and of course this is going to be our answer plus c, the constant. Okay, so thank you so much, and of course ensure you give this video a thumb up, subscribe to our channel, and I'll see you guys in my next video. Bye.